Good afternoon, and welcome. My name is Matt Stephenson. I'm a software engineer. I work on the Java runtime for Google App Engine. Today, I'd like to talk about something that's been very important, what I work on and what I've worked on in the past, which is how to build applications that autoscale very well in Java. Autoscaling is an incredibly important piece of Google's internal infrastructure. It allows us to efficiently utilize the resources that we currently have internally. Autoscaling is an autoscaling environment is an environment with the capability to expand and reduce capacity based on user demands. This is done by over-provisioning machines, typically. And for us, it's really great because we get to have really effective utilization of our resources. For some of you, that might be important. But for many of you, that may not be the most important thing. You may only have one application that you're running. It may not make sense to over-provision and have different applications consume your resource pool over time. So I'll give you a little story. When I was, a while back, I used to work for a large online internet retailer. And I was on call. And it was the holiday weeks. And it was a little bit rough, as it usually was. But they sold a lot of this new device that year, a whole lot of this new device. And I ended up getting paged. This device had a large group of services that supported it, running inside of our infrastructure. And those services were scaled pretty well. That's what the team thought. But they had a big concern. And so I was paged just kind of in a scramble to get resources and be able to deploy their service to many, many instances in a very short period of time, because they had sold a lot of these devices, but not a lot of them had been turned on yet. And the reason for this was that many of them were still in the packaging. And so over the next few days, at specific times, they were expecting these services to get hit really, really, really hard. So in that sense, autoscaling would have been a magical thing for us. I would not have been paged. It would not have been so much use of engineering resources and so much of a scramble to try and find additional computational resources to support this influx of requests. Okay. So what does this mean about Java? How does Java play into this? So Java has an interesting evolution. We started off really small and simple with applets. Those consumed a very small amount of memory. And the JVM was optimized for that. And then we went from there and grew into much larger vendor-specific Java Enterprise Edition servers. And the JVM was optimized to fully consume these pieces of hardware. It was optimized for CPU and memory. And that evolution continued. But at the same time, we started having this really popular thing called the internet. And so really the only thing that people were building with Java Enterprise Edition were web application resources. And so we started to have containers that were optimized for that, things like JBoss and Spring Application Server. And all of that kind of evolved to build out, to fully consume compute resources again. But in that case, it was more commodity hardware. It wasn't the big application-specific, massive machines you were purchasing from these vendors. And again, the JVM was optimized for memory and CPU utilization. But now we're kind of in a new generation of Java runtimes and Java VMs, or usage of the VM, where you're seeing very small containers, things like Jetty, just running very small frameworks like Drop Wizard, and things like App Engine coming around. Along with that, you see that now that you're seeing a lot of Java development in another platform that's about the same size, if even larger than what you usually have in an over-provisioned infrastructure as a service or platform as a service. Because your mobile phones today are massively more powerful than, say, a Google Compute Engine micro instance or an App Engine F1 or even an F2 instance. And again, Spring and JBoss and such are still very widely used, and they're very, very effective on larger pieces of hardware. So what does this mean for App Engine? So App Engine has a Java runtime. We can automatically scale to meet your needs, and it works pretty well. For the average user, you're not really going to see much limitation when it comes to that. So let me give you a quick demo of what that looks like. So I'm just using a pretty simple tool here called JMeter. And if you haven't messed with it yet, then you probably should take a look. All I'm going to do here is hit my App Engine instance that's running with about 1,000 concurrent users 100 times over. So let's just do that real quick. So as you can see, I'm pounding it pretty hard. And let's go take a look at App Engine here. And we can take a look at how many instances I have running. I'm hitting the normal version of my application. So I've got a good deal of instances running here. And these are all pretty healthy instances. They're all responding pretty well. So let's take a look at what this looks like in a graph. And as we can see, we had some loading requests that hit. We were thankfully, sub-second. And everything seems to respond just perfectly fine. So what are some problems when it comes to trying to build a Java application that runs on top of an over-provisioned environment or a platform as a service that utilizes very light resources so that you can do very cost-effective and very powerful autoscaling? So large deployments can be very complicated. And in that I mean deployments that have a very large amount of resources allocated to them. Things where you have very complex dependency structures. Automatically instantiating classes can be overly complex and can be very difficult for a platform as a service to be able to keep up with. Code generation can be very problematic because in many times you're going to be spinning up and spinning down instances very quickly. So runtime generation of code can be very, very, very difficult for these instances, for the runtime to keep up with, as well as if you have security managers and things like that. Managing shared state can be a big problem, and persisting configuration both can be more problems, not really specific to the Java world, but more in general when it comes to just having that many cross-connecting, that much crosstalk with the individual instances coming up. So large deployments. This is an example of just some Maven that I've seen in applications that I've had to take a look at. And these kind of dependencies, whenever you have really complex dependency structures and you end up with a lot of artifacts, it can be very, very difficult to track down what's going on. This is kind of actually what I prefer in terms of Maven dependencies, something really lightweight, using just Juice with Jersey and Jackson. This is more like for if you're building a RESTful web service. If you're building it from scratch, not necessarily using cloud endpoints. Let me show you real quick what it looks like, what I'm talking about in terms of what's going on here in Maven. So I've got an application that's got a pretty complex dependency structure, and I can kind of see that because all of a sudden I'm kind of just downloading the entire world to try and get this application built. Now, if I really want to make sure, if I really want to take a look at everything and see, oh, I'm sorry, it's a little bit small. If I want to see what's going on really in my dependencies in Maven, that's actually really easy. The Maven dependency plugin can give me a really good idea And there's a whole lot of IDE integrations that make this a lot prettier. But as you can see, this is relatively complex. If I wanted to try and make this a lot simpler, I'm pretty sure I could. So let's take a look here. So along with that, the other problem that I see a lot is automatically instantiating classes. This is kind of a problem because it can get a little bit out of control. And if you're using frameworks to do a whole lot of work for you to instantiate and destroy classes and manage the lifecycle of those objects, you can have a lot of problems refactoring later on to try and make sure that you are not accidentally creating objects and such. And one of the things that always gets me about this is that new is a really fast operation in Java. So this is kind of an example of something that I see a lot of people doing where you have a, my goodness, okay. This is a problem that I see a lot of people have with Spring applications. This is an example of using an annotation to try and automatically instantiate a class. So what this is you have a class that's annotated with a specific annotation, and then in Spring you can say, scan the entire class path to try and find any of these classes that I might want to instantiate. The way that Spring does this, and the way that a lot of other frameworks do this, is that they take all of these jars that you have on your class path. So again, if you have a lot of jars, if you have a really large deployment, this can be even more of an issue. It'll take all of these different jars. In this case, in Spring, you can specify a package to filter on. In some other examples, you might find that you can specify regexes on the class name and such. But it's got to go and look at the table of contents of every single jar file, if it hasn't already. Try and figure out which class definitions it might want to go see if they have annotations on. And then in order to get that, to determine if there's an annotation on any of those classes, it's going to read all of those class definitions in. It's probably going to use ASM or something like that to locate the actual annotation itself. So you're not only reading in the bytecode, you're parsing the bytecode, you're processing it, and then finally, you're making a decision of whether or not to instantiate the class. So this can be really, really problematic, and to be perfectly honest, if you only have a few classes, it can be this easy just to have the class instantiated by your framework. And I could do even less code than this and just write new simple movie listener. So what's it look like when an App Engine app is doing a lot of this automatic class instantiation? Let's take a look here. OK, so again, this is JMeter. Really great, Apache JMeter, sorry. Really great program. Let me make sure I've got this all set up correctly. What I'm looking at is I can define an HTTP request underneath a thread group. The thread group's where I define how many concurrent users and how often they're hitting this service. So let's give this a go. Let me make sure I don't have any results here. So now I'm kind of beating up the service again. We can actually take a look and see how many instances I have running. And here I have a few less instances. Well, we haven't ramped up all the way yet, so let's see here. Here we go, we're starting to get there. And we can actually take a look. We should be able to graph these at this point. And so we're kind of now at about 20 seconds to actually get our first few requests in. So this is what it looks like whenever you have an application that you're doing a whole lot of work to avoid writing a lot of code that could pretty easily just be written. OK, back over here. So code generation. This is my code. I wrote this a long time ago, and every now and then I use something like this as an interview question. So if you can spot the most terrible mistake I made in this, grab me. I've got office hours and stuff later. I'd love to chat about how terrible this code is with anyone who wants to tell me how bad it is. The reason this code is terrible in the context of what I'm telling you today, though, is what this is an aspect. It's designed, it's an around advice aspect for Spring aspect-oriented programming, the Spring AOP support. And what it does is it actually creates a little class. It creates a little bit of bytecode that wraps your class. And whenever an exception is thrown, it logs that exception and rethrows it, which is kind of weird. But if you look, I don't know what that is doing. OK, I have a laser pointer. Good. If you take a look here at this @around here, this is called a point cut in aspect-oriented programming. And this point cut in particular is going to be hitting every single public method. So that means that for every single public method in my entire application, I'm going to generate some code and put that in the way. So there's a whole lot of frameworks that just relax to doing this. This is something that you should probably avoid whenever you're building new applications. But a lot of frameworks do runtime generation of code. If you're working in something and you can't really get rid of a lot of this aspect-oriented programming, even though I don't like it, you can definitely do things like use compile time generation of the aspects, generation of the code. And you can also do, with AspectJ, I believe you can do build compile time class bytecode weaving. That's what I was looking for. All right, so what does it look like when we have an application that does a lot of this? So I've got another JMeter demo all spun up and ready to go. Let's make sure that, let's see, yep, that's right. That's all right, OK. Let's give it a shot. So we can actually go take a look again and see what's happening. Now, the interesting thing about doing a lot of class generation is that you're actually going to end up using a lot of permanent generation space in the VM to track all of the generated classes. And that's another thing that's really problematic because it's really hard to tune a VM. And if you're on a platform as a service, do you really want to have to really specify a lot of tuning parameters for your specific VMs? It can be really, really, really troublesome. As you can see, we're spinning up a lot of instances to deal with this. So let's take a look at what this looks like in a graph. Yeah, that doesn't look too clean. We're up at 22 seconds, and now you're kind of seeing this really bizarre behavior where we didn't have that before. You see this kind of arc like this, and a lot of that is you're going to end up spinning up more instances over time to try and handle that versus being able to really blow through it. Oh, I don't really have any data points on this graph. That's unfortunate. OK. Cool. So that's kind of what that looks like. And as a result, that's something you should probably avoid doing in your application. It's not something that's specific to App Engine even, because you're going to end up with this kind of problem if you're using anything that you're going to have a lot of memory, if you're going to end up having a lot of untuned JVMs. So the next few are Java-specific because they're things that typically Java applications have done in the past. So managing shared state, it's kind of not the best idea to do a whole lot of crosstalk between your application instances as they're starting up, if you're starting up a ton of application instances at the same time. And so in this case, we're kind of just grabbing some information out of our persistence mechanism, doing on each request from the user. And this can be really problematic because you're going to end up autoscaling in a very brief period of time, generally. So all of these requests are going to hit some service to try and pull in all of this context. So you have to be very careful not to try and do too many. You can end up doing too many requests on startup with this in these types of applications. And caching can kind of help, but it's not going to be the most effective. Another problem that goes along the same vein is persisting configuration. In the last several years, I've kind of shifted my opinion. I used to be really behind having your configuration persisted in your data store or in your database. The problem with this is that, again, when you have a whole bunch of instances of your application start up at the same time, they'll just pound that back-end resource. This was a big problem back when I worked at unnamed large internet retailer. And so what I've come to do is actually just work on trying to build that configuration into my source code, into the source itself, build and deploy that configuration along with my application, and maybe just keep a few keys available so I can switch in and out a few of those properties. Like say I want to use the my development configuration, or I want to use my QA configuration, or something like that. And what you're seeing in this code here is just kind of something where you're generating some kind of shared secret on the first request and trying to persist it and re-get it. Well, let's see what happens whenever we have an application that does something like this. See how this kind of plays out. So, JMeter again. So we're going to spin up a bunch of instances again, see if we can handle all of this load. And this is our App Engine dashboard here with all of the instances that are running. As you can see here, we've got a good deal of instances. We're spinning up way more. And when we take a look at this graph, we'll see that we're doing OK in general, but that we're still not kind of like handling user requests very quickly for a little while. We're still not nearly like what we have here. And unfortunately, since I'm using the App Engine data store as what I'm persisting all of my stuff with, it's actually kind of fast and pretty performant. So is Memcache. So I'm sorry it's not quite as crazy of a graph. But I could definitely try a little harder. And as you can see, also, I'm spinning up tons and tons of instances to handle this, way more than my other examples. OK. So what are some tools I've been using and that I use to try and work through these types of issues myself? So I, of course, like to use my build tool. And I think that it's incredibly important to have a build tool that will manage all of the relationships within all the relationships between the dependencies in your application. Something that you can easily analyze your entire dependency closure and make sure you're not bringing in a lot of stuff you don't need. Another thing that's really useful is actually ProGuard, and it's something that I've been working on trying to get a little bit more of a paper written up that would help developers use that in App Engine, but it can really help you reduce the amount of classes you're deploying, deploy only what you need, and in those cases, you actually have really good cache locality when it comes to like the network file system that's going to be providing your application to your individual application instances. So that can help a whole lot. And then, of course, I was using Apache JMeter a lot in all the demos. Of course, load testing, people are always concerned about that. But to be honest, well, this is kind of a crazy number. I'm sorry. I was going to reduce this. But it's cost me about $9.41 to run this demo. I don't know how many times now. It's not that expensive to just do some simple load tests. Let's see. AppStats is also a really great piece of, a really great tool. It's really useful for profiling all of your back-end RPC calls and making sure that everything is smooth from that perspective. So go forth and scale. Build applications that scale well. Build applications that are very simple, things that you have very strong static analysis tools for. And have fun. My office hours are tomorrow, 10:15 to 11 a.m. We're at the Cloud Sandbox. And feel free to come hit us up. Are there any questions? Please. Yes? Yeah. there's a microphone. Do you want to use the microphone? Yeah. Or you can repeat what you're saying if you don't want to use it.
So a lot of things you're doing is trying to simplify the application so that the footprint is smaller, right? This is,
yes.
But the other hand, a lot of frameworks trying to simplify your workflow to make things simpler. Where do you reach the balance, between writing everything in your code versus making it simple and tuning it? And would you do that first when you're starting off a new app?
So that's an interesting point. I think that there's a really good balance there, and the really good balance is usually, I actually can use testing a lot, testing my application and testing assumptions of my application to try and strike that boundary. Because if I want to really test my application, and the frameworks that are associated with my application are a part of that, I do need to test some assumptions about those frameworks. I can't just go on those frameworks on face value. So when it comes to trying to leverage frameworks to simplify the amount of code you're writing in your code flow, it means that you're going to end up writing a lot of tests to make it so that you can be able to understand what's going on under the covers with those frameworks. So at a certain point, you can kind of strike a boundary of saying, look, if I introduce this framework, I have to think about also all of the tests that I need to write to make sure I understand all of the assumptions that I'm bringing into my dependency closure. From that kind of helps me understand if a framework's going to be valuable or not. And I mean, I have to play with it a bit, usually myself, to make sure that it's what I really want to use. Is that good? Cool.
Hi. So let's say that you finally convinced your employer that dependency management tools are a good thing.
That is great.
and then they turn to you and say, OK, we don't want an instinctual answer. We don't want your gut reaction. What we want you to do is we want you to go and actually assess them and report back to us what you can about the different tools. We really want to make an objective as opposed to an emotional decision here. Do you have any advice for me on how to move forward doing that?
So I guess my objective stance on that is to, if I want to objectively evaluate different build tools and different dependency management tools, it's best if everything's kind of working together really well. So having something that's very mature is useful. My personal preference has ended up being Maven for right now. I like Gradle, but Maven ends up, everything kind of works together as long as I keep it simple, So I think that having a full build tool set that works together really well is really important, testing that out, and then being able to, the other thing that's really great is IDE integrations. So, which was one of the big reasons why we got behind Maven on the App Engine team, was because then all of a sudden, IntelliJ is a lot nicer, and everything's a lot nicer. NetBeans is a lot nicer. So I would say IDE integrations and having a tool set that's complete and whole in and of itself.
Thank you.
Is that good?
Yeah, thank you.
Hi, we use Spring MVC quite a bit in our applications, and you give the example of doing the single bean instantiations. Could you give any other tips for optimizing Spring MVC applications on App Engine?
Yeah, so if you're doing, so Spring MVC is really big on the automatic instantiation of classes. And there's there's potentially a lot of AOP that you can get mixed in there if you're using some of the security features in Spring, I believe. And so those two, you kind of have to be careful with what all your, whenever you're using Spring AOP in there, what all you're going to be surrounding with advice. And then I would also say that trying to use lazy initialization wherever you can for beans. Lazy initialization is a really careful one, though, because whenever you use lazy initialization, you're going to be creating a lot of extra classes in the middle there. So yeah, and the reason to do lazy loading is to try and amortize all the cost of starting up your application over time.
Great. Thank you very much.
Sure.
Hey there. Just two-part question. Do you feel like you had a lot of good anti-patterns, and reducing the amount of libraries and dependencies seems like a good idea? Do you feel like there's a correlation between more realistic applications and more larger uses of more libraries? As opposed to a load driver that you were showing?
Yeah. So I would say that for applications that are built where you have a single instantiated app, like a single version, a single piece of that application is instantiated at a time. So if I'm building a very large application, I generally build a lot of different smaller services that I'm going to run behind that application.
Exactly.
And with those services, each one of those, I'm pretty careful to make sure the dependency closure is very minimal. And so in a lot of cases, I can reduce how much overhead I have in my application just by constraining, like splitting services. In a way, there's, it's really nice to have your services split out very logically, but sometimes if you split out services just to be able to keep the dependency closure constrained,
I get it.
you can really gain a lot of value.
Decompose for scalability, yeah.
Yeah.
Okay. And then, I heard a couple of other people remark on this too. Obviously frameworks are here to stay and there's a lot of value in them. What are you guys doing to make frameworks work better on App Engine as opposed to saying, hey, you have to choose, right? Put your configuration in your code where it's hard to manage over time, or you know what I mean? Stuff like that. Like, what are you guys doing to make it work better?
So one thing in particular is for Spring MVC, if you're using the context component scan, I was just like talking to Jürgen over at now, I guess, Pivotal, who is...
Disclaimer, I work for Pivotal.
You work for Pivotal. You weren't on the phone with me, were you?
Maybe I was. I don't know.
So we were talking about, and I owe him a pull request to try and help get some jar indexing in, kind of like what JBoss does. So they have like a project called Jandex that indexes all of these classes and indexes the annotations on them, and then they can actually call back into that and create classes that way. So you're not going and spinning through tons and tons of jar files whenever you're trying to find classes that might have a specific annotation. So that's one thing that I've been working with framework providers to do. And then the other thing is just basically fixing bugs. Like I'll go on there and sometimes just send pull requests to fix bugs for things that I see here and there.
Cool, thanks. We're excited to work with you too.
Cool.
It seems that a lot of the discussion that you had is around optimizing startup times.
Yes.
And that is especially important when you have a lot of smaller instances.
Yes.
Does App Engine, or will it ever support more coarse-grained scaling such that you have fewer instances and therefore less of this kind of problem?
So are you asking about having larger instance types, or?
Yeah.
Okay, so we have like F1, F2, F4. F4 is a pretty big for front-end instances, and we also have back-end instances. And I think probably if you come to the office hours, or if you actually come over to the cloud booth later, I can point you to the guy, or I can make sure I find his office hours, who is working, Troy, who's working on the servers project, which would be like really along the lines of what you're thinking about, I think, which allows you to have much heavier weight machines.
But that's something that the developer would have to look at specifically and say, we can't make this startup any faster.
Yeah.
We're going to have to go with a different instance size.
Yeah.
There's really no.
Yeah.
Okay.
There's a couple other projects going on, though, like Cape Dwarf is an open source alternative to App Engine that's capable of running on some larger instances.
How do you handle applications with very large memory footprint in the App Engine world? Like where they would like to load a lot of static content in memory, like 10 gig, 20 gig. Do you find issues with the garbage collection?
Yes. Very large applications, first of all, if you have too large of a memory footprint, it just won't start, because we do have very small instance sizes.
So is there a limit, like what is the maximum you can go in App Engine?
There's, I would have to pull it all up. I believe for F1s, it's pretty small. It's 128 megs. Like we have really small instances, and then we get up to, I believe, 1 or 2 gigs on an instance. Maybe it's half a gig. I would have to go look it up. I don't remember off the top of my head, but it's pretty small. So running consuming a lot of memory on an individual instance can be problematic from that regard. It also can take a little while to get the instance up and running, because it's just going to be, you're going to be continuously trying to allocate memory inside of the instance. And if you're in a really, really over-provisioned environment, you could end up, even outside of App Engine, if you're using something like OpenStack tiny instances and trying to auto-scale with something like that, then you can end up with if you're oversubscribed for memory on the machine, then you can end up actually, like the virtualization software will actually start swapping out some of that memory. So you end up with a lot of problems if you're consuming tons and tons of memory.
But if you have applications which are like loading a lot of content and they require like 8 or 10 gigs, means how do you guys handle the garbage collection part? Do you continuously try to optimize the JVM parameters, or you try to?
Yeah, we're always looking at them and trying to optimize them.
Okay.
Yeah.
And is the JVM used in the App Engine is the same from the Oracle like hotspot one, or is it a different flavor of it?
I don't know if I should say on camera too much about that, but
Okay.
It's pretty close. You wouldn't notice a difference.
Okay, thank you.
Hey, how's it going? I'm not on App Engine now, but I'm considering about using App Engine. And one of the questions I have is actually about being able to profile, right?
Yes.
I'm assuming you don't get the profile in the box. How do you guys manage being able to use some sort of profiling tool, or what do you guys suggest to profiling your application that at least replicates some sort of environment on the cloud?
So I've been trying to look at building better profiling tools for developers. There's some stuff that we have helped people with in the past along those lines, larger customers. It's very difficult to make something like that really work well where it's not interfering with your application. But AppStats is really great for profiling all of your out-of-the-VM calls. So all of your calls to like going to getting things from the data store, things like that. AppStats is really effective for.
Does AppStat provide, for instance, you were talking about on startup, class creation and things that happen on startup. Does AppStats provide insights into that, or?
No,
mind you, I apologize. I'm not so familiar with App Engine.
No, not yet. But like I said, not yet. I was actually going to try and hack that in at some point. So that was one of the things. That's one thing that I'm looking at, is how to get a lot more of those statistics out there in a way that it's going to just be information that's pertinent to you. Because right now, if I try kind of shoving those types of metrics in, I have to be a little bit delicate not to munge up what we're doing with what you're doing in your application.
Right. Yeah, it's extremely important, I think, for like super large scale usage to be able to dive into your application and see what's happening. So if you get around to hacking to it, it'd be very useful. Thank you.
Thank you.
Can you talk about whether you use Omega behind App Engine?
I couldn't hear you too well.
Can you talk about whether you use Omega behind the App Engine?
Omega?
Yeah.
I'm not familiar with it.
That's the cluster scaling system. You have a paper on that. Google Research has a paper on that.
I'm having a hard time hearing.
It's like the Mesos thing you developed.
Oh.
Yeah.
Yeah, to my knowledge, no, we don't.
Okay.
I got here a little late, so I'm sorry if this question's been answered. But I've had the opposite problem where I have really, really small request servlets. And I think there's a limit in App Engine that you can only have like 10 concurrent requests handled by one instance. Is there any plan to increase that? I think it was some legacy thing with memory issues. Like, what's your reasoning behind it? Is there a story around this?
Those types of limitations have been with it for a long time, been with App Engine for a long time, and a lot of them do need to be reevaluated. So I would say, I'm happy to take a look and see what we can do about that. That's a good suggestion. I'm on, you can, hit me up on Stack Overflow, or you can hit me up on the App Engine IRC channel on Freenode too.
Cool.
And yeah, let's chat about doing that. That would be cool.
Sounds good. Thank you.
I like that.
Does this problem happen with Juice, when you use Juice with App Engine?
Oh, Juice. I like using Juice a lot. There's a couple things in Juice that are kind of weird that I avoid. The circular proxies in Juice create a lot of problems with creating extra classes to deal with you haven't had both classes fully initialized yet. And circular proxies are just kind of weird. And then I try to avoid automatic injection, but that's more of just a personal preference, I think. The thing that can kind of go sideways with App Engine and Juice is if you have a whole lot of modules, a whole lot of separate modules that are all being composed together. I'm kind of cold on this question. I haven't looked at this in about 2 months now, so I'm trying to get my context back, but I believe there's a validation step that Juice goes through that does end up doing a good deal of introspection of the application's class path that can be problematic like that. Is that good? I don't know how much more time I have. Any more questions? Cool. Well, I'm here all week. Me and Ludo will both be at office hours tomorrow at 10:15. That's kind of the official time to come find us, but I'm going to be running around the conference a little bit, but mostly over at the cloud desk. I'll also be helping out with the Cloud Data Store code lab at the end of the week. And so that should be pretty fun. Thank you.